Now I can look at those two features together using a facet grid. So the facet grid is a seaborne way to create multiple plots where you're splitting those plots out by the row and column values, which are going to be categorical variables. So for instance, I might want to look at the interaction. The example I have is about tips, and you might look at the time of the meal, whether it's lunch or dinner, and the sex of the diner, whether they're male or female. In the example that we're looking at, what they're doing is they're creating a place for a column by time and a row by sex, and then they are mapping that to a histogram plot. So you're seeing different histograms that show you how these are distributed. And if you look at this plot in terms of the tips data set, you can see, for instance, that first of all, there are more male observations because there are more bins. You'll also notice that if you compare the distribution for lunch with the distribution for dinner, it looks like maybe the outliers go a little bit further out. Maybe there are some higher tip values for dinner, which kind of makes sense. People typically, in terms of our Titanic example, we don't know where they embarked influenced that, but we could go ahead and create a facet grid object and see if we can wrestle with it until we can make it work the way we want it to. So I'm interested in looking at the interaction between sex and embarked, and then I can do what looks like I should do is map data frame, and I want to use a bar plot because I've seen that bar plots are helpful to me. And do I get to set additional arguments for that? I guess that I need for y to be survived. So you see how this interacts. I'm hoping that I can set CI to be none also. And it looks like I can. So let me see if I can make this bigger. Maybe I can set the height height argument explicitly here. I'm not sure. Okay, so that's more visualizable. I could definitely mess with the aesthetics of this, but in looking at this, you see that women tended to survive at a rate. You can see the relationship. So your best probability of, actually, let me change the rows and columns here because I prefer a landscape layout. Okay, so that I think gives pretty good information. Can mess a little bit with the aesthetics. Let me change it so that the height is a little bit taller because now I can get more in. And okay, so you'll notice that for males, you had a better chance of surviving if you were coming from class C. But males didn't have a very high chance of surviving overall. The male survival probability was about 30% in the best case. And then you'll notice that for this, the lowest value is if you were a male who embarked at whatever Q was, then you had a very low probability of survival, about 10%. So males who embarked at Q had basically no chance of survival. If I look at that same thing for females, again, if you were a woman, a female on the Titanic, you had a better than average chance of surviving. Your survival rate was much higher. But again, for whatever reason, C had the highest survival rate. And what's interesting that I'm not sure how to interpret completely, but I do also see that the situation with S versus Q is reversed for females, but in neither case is it really that significant for males versus females. So I could summarize this by saying something like C had a higher proportion of survival than the other classes. Women had a much higher chance. And that is helpful information. I feel that anyone, whether they understood any statistics or not, could look at that sentence and gain information from it. And that's the goal, is to organize the information that we glean in such a way that other people are able to know something about it.